Aviation University. She holds a Bachelor of Humanities from the University of Cyprus, a Master's of Science and Technology in Aviation Safety from the University of New South Wales, as well as a PhD from Coventry University. Right. So her expertise is in human factors in safety management systems, and she provides consultations to aviation organization. Her research field includes human factors, safety management systems, safety management practices, influencing the performance of safety management systems, safety culture, national culture, and reporting system. Without further ado, please join me in welcoming Dr. Crystal. I would also like to remind you to keep your cameras off at all times. And if you have any questions, please type them down in the comment chat below, and I will pass it to Dr. Crystal. Dr. Crystal, the stage is yours.
Thank you so much for the introduction, Ala. Bienvenidos todos. So today our presentation will be on human factors in SMS. So let me start the presentation, and I will also want the participation of the audience as well. So I will go like this. So can we all see the presentation?
Yes, I can see the presentation.
Perfect, perfect. So I will need the I will need the participation of the audience as well for some slides in the beginning. So human factors, in SMS. So you can feel free to open your microphones here in the first few slides. So, like, what is the problem here? What do we see here?
Unfortunate event.
The crash?
Crash, I agree. I completely agree with you. So we have crash here. So one is Air Ontario and the other one is BMI here, British Midlands. Okay, let me continue to the next slide. Here, what else do we see here? So what happened here?
The windshield came off. That's probably because the bolts were not of the proper size.
Exactly. And what about the second one?
ATC.
Was like only ATC? What do you think?
It was the pilot error, miss. Overconfidence and arrogance caused the accident.
I completely agree. I think most probably we have done this in one of our classes, I think. So the problem here, like what do all of these accidents like this one's here, Air Ontario, BMI here, and BAC 111 here, British Airways 5390, and Tenerife here, like what do these like have in common? Like who caused like the accidents?
Human error.
I agree here. Okay, so let's go here. What I want here is, I want everyone with the phone to scan this QR code and like give your opinion, and then we'll discuss the results like in 2 minutes. Like scan it with your phone, with the camera, and then like choose the options you like. You can choose as many options as you want, and then we can discuss. So let me see here. Let me prepare here the results so we can see what people are saying. Perfect. Okay, let me see. Most people are done, I think, here. Okay, let me share my screen here, and let's see what people like here answered. Okay, so I will go here. I will just share my screen here. Okay, so let's see here. So 41%, 41.5% answered like the problem here is humans. And then another like 25, like almost 26% answered management. And then 11.11%, let's say, answered organizations, then almost again 11% like the aircraft, and then 7.14% answered culture. Then we have people entering like maintenance, equipment, environment. So here I completely agree. So if we can see here, like we see humans here, and we see other factors, like what are like some conclusions we can draw from this figure here? What does this tell us here? What do you think?
That we are the main cause, like since we are humans, we are most probably into fatigue or stress or some other issues that we are facing. So we unintentionally make errors or mistakes.
Exactly. Someone else wanting to add something else, I think?
Generally, I think it's human beings are prone to errors. So yeah, protocol.
Exactly. So here, this is again, it confirms like the statistics that say that like the majority of aviation accidents are caused by human errors. So by people basically. So 70 to 80% of aviation accidents are caused by people, but as this like chart here, this pie here tells us, is that we have other factors here, as we can see, that push the people into making the errors or in the way they act. Perfect. Excellent observation here. Let me go back to the slide here. Perfect. So I will go here and continue from here. Okay. So what is the solution here? So here we have a Helmrich's figure here. So in this Helmrich's figure, what is the solution to aviation accidents here? Now, the first thing to do is avoid error. So first of all, we have to try to find ways to avoid errors. So by having procedures, training, in duplicate inspections, for example, here, these are ways to avoid error in the first place, since we know that, again, the majority of accidents is caused by people. Then the second stage would be trap the error, meaning that if something goes wrong and we have an error, we have procedures procedures here in order to trap this error and capture the error and correct it, like duplicate inspections in this situation, and correct it before this results into an accident. And the top of the triangle here is mitigate the consequences of error, meaning that if the error does happen here, we need to have a system that this error is not going to result into an accident. Like we have some sort of like tolerance, and if someone makes an error, there is a way for us to correct it in the end, or correct the consequence of this error. For example, this would be, I am doing an assignment, or I have like a folder, like a Word document. I accidentally delete this document. So this is an error here. Now the issue here is, can I mitigate the consequence of this error? Yes, I can, because I can go in the garbage bin and I can retrieve this document. So here, the way the system is designed is with the software, or like the way computers are designed in a way knowing that people eventually make errors, but there are other ways here to minimize the consequences of these errors. So possible topics here we discuss like in human factors. So here again, we have people, and people make errors or people make violations. But for us, and especially like in aircraft accident investigation, we can come early in the pretty early in the conclusion and say this like accident is because of human factors. But the difficult part when it comes to aircraft accident investigation is to understand why did this person act this way? Like, why did this person did this action or did not do up to the standards? Because there must be a reason why the person did an error. So what we're doing here is we're going behind the human factors, trying to understand what made the people act or did not act in the way they should have. So possible things we see in human factors is decision making. Why, like, how do we take decisions? Who pushes us to take a decision, for example? We have stress, fatigue and sleep, communication, which means poor communication or lack of communication. We have psychology, automation, organizational culture, which we're going to discuss like later on. A huge topic in aviation, and especially when it comes to the culture of the organization, safety culture, national culture. So here as well, when it comes to, again, human factors and the way we investigate accident, we also investigate how certain nationalities act. So we have studies, for example, that show like how certain nationalities use the automation of aircraft. So we have physiology, like how the body works. We work with accident statistics and ergonomics, which is coming soon in the next slides. So a story of human factors here. So human factors is actually a relatively new discipline that started just like after World War II. And it's like based on aviation medicine and psychology. So here, human factors is actually, it's a discipline that is supported by other disciplines, by different parts of science. So for example, human factors include medicine, psychology, sociology, the interaction with the society, with other people. It has to do with ergonomics, like designing for the people, management, national culture, etc. So human factors now is a more integrated and focused on overall performance, not just accident prevention. So now, like, we as human factors, we are trying to understand how all of these factors around us impact the way people work. Okay, so the need to take into human factors to take human factors into account. So here, as we can see, this is like the Wright brothers in 1903. So in like the early 1900s, when we designed aircraft, and of course at those times we have aircraft crashes. So we knew that these aviation crashes were because of like bad design. It was just the beginning of aviation. As time passed, we started to build better aircraft, and especially during the World War. So during the World War, there was a need to develop fast aircraft to be used during the wars. So then we started to develop like better aircraft, yet we still had aviation accidents. Then later on, as we still had aviation accidents, we started to understand that, it's not like the machine which is causing the accidents, it's actually people, because now we design better aircraft, we have better standards, yet we continue to have accidents, so there must be something else other than the design of the aircraft. And this is where we started to understand that we have human factors. It's like people causing the accidents. So before discussing like how these accidents are related to human factors, we have to give a definition of human factors. Now, some people here refer to or call human factors, they call human factors or define human factors as ergonomics. So in your opinion here, like, have you ever heard this word before? Do you know what ergonomics are?
Yes, miss.
What is this?
Ergonomic is like, if you take it in orthopedics term, it is your comfort basically. So how your body is going to be comfortable towards your posture is ergonomics.
Exactly, exactly. This is exactly it. So here in ergonomics here, it means we're taking into consideration the human measurements and the way people are, the nature of people, and we design for the people because the nature of people cannot change. This is how people are. Like they have like the approximately 95% of people, like they have these dimensions, like the hands like from here to here. Like so we have like certain numbers here. So we're designing for the nature of people here. We know that people are designed in this way. When it comes to performance, we have certain limitations here. So taking into consideration the anthropometrics, which means the human measurements, the taking into consideration the anthropometrics and as well the human limitations, it means we're designing here to accommodate people. So I'm gonna go here. What is this here?
These are the levers for the landing gear as well as the flaps in the cockpit.
So what do you think? Like it is, do you think there is an issue here with these like levers here? Can anyone
Yes.
A doctor, I
identify a
cannot see
problem?
the slides.
Can everyone see the slides?
I think I cannot.
Well, from our end, we do see the slides.
All right, I'll try and rejoin.
I think maybe, yeah, I'll start most probably. So what like do these levers, like do you think there is an issue with these levers here?
Yes, doctor. So these are damaged and these are not very comfortable, or in other words, you can say ergonomic to use.
Exactly. So I want you to imagine here that we're flying the airplane. We're in the 40s during World War. We're flying the airplanes, and of course, it's old airplanes. They don't have much automation on them, and it's nighttime. We're flying these like not very automated airplanes. And we're also like really tired, like we have because of the workload, because flying at night, flying like again with limited automation here. What could be a problem here if these two levers are next to each other? And again, it's nighttime as well.
You have chances of missing.
Shall I start first with Bhagavad Farana first, and then we'll go to the next opinion?
Sorry, Doctor. Good morning. I think you're flying at night. First of all, they are not visible. You only distinguish them by the shape. If you can sense it with your hand, that's the only thing. And in the hurry and in the stress of the battle, well, who knows what lever you press.
Exactly. And this was exactly the problem here. So let me go here. What do we think here? What is this here in the cockpit?
That's the landing gear lever.
Exactly. So here,
And well, it's what I see is something that well, in the main flat surface of the screens is something that it's so visible. It's something like you have a hanger to hang something. You cannot miss it. You cannot miss it.
Exactly. And this is exactly why it was designed like this. And we're going to say, like, we're going to discuss that story like in 2 minutes. This is exactly how this design resulted. And then let me go to the next one. Like this. And look at the flaps as well. Like, what is that? Like, look at the shape of the flap. it looks exactly like a
Wing, airfoil.
exactly. It looks exactly like the flap. So what we can see like nowadays in the cockpits, it's the evolution of this here. And how did they come with this like change here? Next slide. So here, what we have, this is the B-17 Flying Fortress, and was used in World War. So this is like a short, like a case study here. So what happened here is they were using this aircraft during the World War, and there was like a design flaw, and this aircraft kept crashing. And after this aircraft kept crashing, they shifted the thinking here to fix the error from what they were thinking here. It was like the machine here, focusing now on the people using it. And how did this start? So here, the B-17 Flying Fortress was rushed into wartime production and went from design to an actual plane in just a year. So imagine, now it takes us like at least like 10 years, I mean, to design the aircraft, test the aircraft here before we certify the aircraft. Here they designed it and started producing it in 1 year because of the World War. So I'm in time to make a real difference to the world, but some strange things kept happening. So the planes kept crashing unexpectedly, usually during what would have been a routine landing. By the end of the war, there had been thousands of such crashes of this aircraft. So they were generally attributed to pilot error. So they were saying, okay, this aircraft crashed. It is like pilot error here. So wartime had necessitated quickly training a lot of new pilots. So because they were training pilots quickly and this aircraft were crashing, they were saying, okay, it's because the pilots are not trained like sufficiently. And this is why we have these crashes. But in many cases, the pilots survived and couldn't think of anything they have done wrong. So when they were interviewing them later on in the accident investigation, they could not think of anything of like doing any mistakes here. On the other hand, there were no issues of mechanical malfunction on the aircraft. So I'm gonna go here. So the accidents, of course, like they remained a mystery, and they were trying to figure out what was the problem until two psychologists, Paul Fitz and Alphonse Chapanis, here in the picture here, tried to answer the question here. So the question here, the problem here was that when pilots were, it was nighttime, they were trying to land the plane and they were tired, it's nighttime, they go like this to pull the landing gear, and instead of pulling the landing gear, they were pulling the flaps. So instead of basically landing the aircraft, they were basically driving the airplane on the runway. So here, Alphonse Chapanis here realized that actually this is not like a pilot error. This is like a design error. And he was the first one to understand that people are making errors because of the bad design. And this is how we started to this is actually how we came with the definition of ergonomics. And here, Alphonse Chapanis is considered the father of ergonomics because he understood that the reason why people were making errors was the bad design. So here, according to the dictionary, according to Merriam-Webster here, definition of ergonomics, it says an applied science concerned with designing and arranging things people use so that people and things interact most efficiently and safely. And this goes back to the example we have discussed, because we know, for example, that people, they have this nature and they're designed this way. And it has been like this for 2000 years, like Cicero in the Roman Empire, he was the one who said it is in the nature of people to err, knowing that this is, again, it's people it's in their nature to make errors. Now here, because we know that this is the nature of people to make errors and people have limitations here, we have to design things to accommodate this nature of people, knowing that they can make errors if things here, proper workplaces or proper equipment here or tools we're using are not designed for the needs of people. So here it gives additional definitions here, and it says human factors. To clarify this here, for us in human factors, we don't really consider ergonomics equals human factors, because human factors includes other disciplines. Including human factors include psychology, physiology, decision-making, information processing, culture, safety culture, organizational culture. So it's not equal to ergonomics. For us, ergonomics is just a part of human factors, but it's not directly like ergonomics equals to human factors. Ergonomics is only a part of human factors. So here, some see human factors as a scientific discipline, and others regarded as a more general part of the human contribution to system safety. Although there are simple definitions of human factors, like fitting the man to the job and the job to the man, a good definition is the one below. So before I go to the definition, I want to comment on this sentence in red, because it says fitting the man to the job. I know that people have certain limitations. So for example, when people are flying this aircraft here, like this, at nighttime, if I don't design properly the interface, the cockpit here, it means I am actually helping them into doing an error. So here, knowing that people have certain limitations and they can get tired, they cannot sleep properly at night, if I don't design taking into consideration these limitations that people have, it means in the end, I'm going to help them into making an error. So this is why here we have to fit the man to the job here. So we have to design for the people, because we cannot change the nature of the people. But as well here, fitting the job to the man, meaning that the job, the task that we're going to give to someone, it has to reflect the capabilities of this person. I cannot give a fish the task to teach because it doesn't have these capabilities here. So we have to give to people what they're capable of doing. So the definition here, so human factors refers to the study of human capabilities and limitations in the workplace. Human factors researchers study system performance. That is the interaction of maintenance personnel, people working in aviation, the equipment they use, the written and verbal procedures, the rules they follow, and the environmental conditions of any system. So here, there is a difference here, because when we're investigating and when we're talking about human factors, we're not only thinking of the people as individual people. We're trying to see the people in a system. So how, for example, here the environment affected the people, or why people, for example, don't follow procedures. If the procedures are not written properly for the people, it means people will not follow the procedures. So these are things we're investigating. For example, if we get reports and when we're investigating accidents or incidents in the organization and people are not following procedures, this is a human factors. But for us, there is a deeper problem, because we have to understand why they're not following procedures. If the procedure is complicated and they cannot understand the procedure, then it's not the people's fault. It's the procedure's fault, because the procedure is not designed or written properly for people to understand. So again, we're investigating human factors here in a whole context, not individually like the human factors. We have to find the whole context to understand the performance of the people here. So the aim of human factors is to optimize the relationship between people and systems with a view to improving safety, efficiency, and well-being. So again, we're investigating people in the system because we're trying to understand how did this system here influenced or affected the people in the way, for example, they took a decision. Because, for example, if they have the pressure of the environment, like, for example, there is like bad weather and they feel that they want to land now because if they don't land, they might have to divert. Here, the people took this rash decision because they were influenced by the environment. So the way we investigate now accidents has actually changed. We're not only investigating the people as individuals, we're trying to understand the whole performance of the people and how the whole environment, again, is influencing the individuals into acting in a specific way. So here we have the concept of safety. So within the evolution of safety and the way we started thinking of safety is we have to take into consideration human factors. So while the elimination of aircraft accidents or incidents here remains the ultimate goal, it is recognized that the aviation system cannot be completely free of hazards and associated risks. Human activities or human-built systems cannot be guaranteed to be absolutely free from operational errors and their consequences. So what we have to remember when we're trying to manage safety here is, as long as we have people involved in any activity, designing aircraft, flying aircraft, maintaining aircraft in organizations, as long as we have people involved, people will make errors. And as long as we have people here, it means that we will have as well accidents. Now, we cannot say I will have 0% of accidents or I'm going to have 0% of errors in my organization. This is not realistic. This is not a reality. This is not going to happen. So even though we're saying, like, people are saying, we have 0% of errors, 0% of, I don't know, incidents, technically, this is not true, because as long as you have people involved, people will make errors and you will have accidents. But what we're trying to do here with safety and the way on addressing human factors is we are trying to reduce the errors and the numbers of accidents as low as reasonably practicable. It's not realistic to say I'm going to have 0. This is not going to happen, because as long as people are involved, someone will have a bad day. But what we're trying to do here is we're trying to keep it as low as possible. We cannot accept to have 100% of errors or 100% of accidents. This is not acceptable. This is not safety. But the ultimate goal here is to address the human factors, and again, the factors around the people, and try to minimize the number of accidents to have a number which is acceptable, as low as reasonably practicable here. So here we have the evolution of safety. So this is like the history of aviation safety and how this started. So we have three eras in the evolution of safety. So first of all, we have the technical era, which started in the 1900s when the Wright brothers flew the first aircraft at Kitty Hawk in 1907. So the technical era from the 1900s until the late 1960s, aviation emerged as a form of mass transportation in which identified safety deficiencies were initially related to technical factors and technological failures. So in the beginning, when aviation started, we had aviation accidents. But these aviation accidents were usually caused because of design failures and mechanical failures. It was the beginning of aviation. We did not have experience. So it was just the beginning. So the focus of safety endeavors was therefore placed on the investigation and improvement of technical factors. So their goal here now is they're trying to develop better aircraft and to design better aircraft. By the 1950s, technological improvements led to a gradual decline in the frequency of accidents, and safety processes were broadened to encompass regulatory compliance and oversight. So by the 50s here, we started to have we started to design better aircraft with some sort of automation here, and then we started to have some sort of regulations as well, where we have certain standards here and authorities overseeing the organizations which design the aircraft. But still the focus was on the design of aircraft and on the mechanical features of the aircraft. Then the next period here, in the early 70s here, to the late 90s. So we have the human factors era from the early 70s until the mid 1990s. In the early 70s, the frequency of aviation accidents was significantly reduced due to the major technological advances and enhancements to our safety regulations. So here in the early 70s, we have even better aircraft with even more automation. So we have enhancement and we have better regulations when it comes to certifying aircraft. Aviation became a safer mode of transportation, and the focus of safety endeavors was extended to include human factors issues, including the human-machine interface. So here, and this was in this BAC 111, it's British Airways Flight 5390 in 1990. This is where they discovered that it's people, now we design better aircraft, yet accidents continue to happen. So now, most probably, it's not the design that is causing, or mechanical failures which is causing the accident. Most probably is actually people here. So now we started to focus on human factors, and we started to focus now on the relationship between the people, the interaction of the people and the machine. So this is the human-machine interface. We want to have a good relationship between the people and the machine, and design, again, the machine to fit the people. So this led to a search for safety information beyond that which was generated by the early accident investigation process. Despite the investment of resources in error mitigation, human performance continued to be cited as a recurring factor in accidents. The application of human factor science tended to focus on the individual without fully considering the operational and organizational context. So in this period, we started to understand that people make mistakes.
The Emirates Aviation University and the UTN team understood the educational problems of our industry. and we know that universities are the space for the training and development of the next generations of aeronautical professionals. With the aim of achieving a cultural exchange, the new talent for aviation has been originally conceived by the group made up of the research department of the Emirates Aviation University and the Aero Commercial and Air Transport Department of the UTN, Martin Konk, Roberto Eriksson, and Fovio Raulchar. Throughout these presentations, we have worked so that our students are the protagonists. This leading role dedicated to our students also has another objective, that our next generation in aviation has more and better resources to innovate, and with a global vision of the industry. Especially in the teams led by the research director of the Emirates Aviation Universities Indoga Mutava Raik and Omar Shafiq, who have made available time and resources to make the NTFA possible. So that the audience knows the fundamentals of the NTFA, we want to tell you that it has been created so that our future graduates and professionals who work in the aviation field today can work together on industry issues. Our aviation, from the Chicago Convention of 1944, is pronounced in its 19 annexes as a single activity involving all member countries. Beyond the problems of countries' resources and policies, aviation became a globalized industry long before the world began to talk about globalization. But until now, in much of the world, when companies in the aeronautical sector need to incorporate new collaborators, about 95% of the personnel interviewed do not have prior aeronautical knowledge or formal education. This situation generates a real financing problem for them, since once hired they will have to instruct them in a very short time and, in some cases, the previous one adds a collateral problem of cost and direct loss. Since after the trial period, must discard a high percentage of personnel for not having been able to adapt to the current requirements in the industry. These two institutions that today make up the new talent for aviation, understood the problem and have developed programs that value training and education, receiving formal university academic education. Thus, establishing a dialogue with your future employer using the same language. The university's aeronautical education establishes a direct link between the graduate's need for job placement with the job opportunities that the industry and the employer can provide. The NTFA kicked off with two brilliant presentations by leading professionals from Emirates Aviation University. Aviation Industrial Studies, by the engineer Mr. Hisham Abuzala, responsible for Emirates Engineering Management of Total Product Support and Suppliers. About the systemic tools that we have in our industry aircraft, Dr. Crystal Ioannou told us about aircraft safety and regulations. The National Technological University presentations will address the following topics. Fuel efficiency, with the contribution of engineer and captain and instructor A320 Roberto Eriksson and graduate student captain A320 instructor Gabriel Gator. The pandemic impact, by our graduate students, Maria Grazia, Julia, Augustina, Mirna, Egle, and Marco, accompanied by Professor Konk, gave us their vision of the impact of the pandemic in Latin America region, but providing a solution to possible conflicts that we may have in the future in an equal or more complex situation, with the contribution of Annex 9. And the last presentation, Personal Influences on Aviation Operations, by the graduates from UTN. Augustina will give us an introduction to what our research led us to a new look at human factors. Leonardo, Damien, Julia, Maria Grazia, and Romina will introduce us to the basic concepts of personal influences that will be treated in depth in the next editions of NFTA. These topics are addressed by UTN graduates and teachers, who have worked as a team to achieve the proposed objectives. These objectives are, the graduates investigate and the teachers accompany the investigation, so that on a day like today, we can show the aeronautical community that the search for solutions to our problems can be addressed by the university. That distances are not an obstacle to the interpretation and resolution of problems common to the industry. Aviation will continue to be a cultural link without borders. It is our wish as UTN graduates that at the next NTFA we can work together with our peers from the Emirates Aviation University on common problems.